So one thing, if for some reason I'm teaching class and you don't see the little red dot up there, tell me. That means I forgot to record it and you don't get to see what I taught. All right. So this is my website. You'll see all the information there. So you'll see here we have the course syllabus. Homework for this class is going to be on WebAssign. I'll go over that a little bit. The course code you're going to need is right there. I do use Google Meet to record the class. So if for some reason you're sick, you can't get here, your car broke down, your kid's sick and you can't leave them alone, whatever happens to be, send me an email and just let me know you're going to join online. That's fine. I'll just remember to invite or accept you when you pop into the room, and you'll hear and see everything I'm doing in class. You probably won't hear the questions people ask, but you'll at least be able to hear the lectures. And then also you'll see the class notes here. So exactly what I'm writing on the board will be posted in the class notes there. So don't sit there and spend a ton of time trying to copy every little thing, like especially if there's like a block of text on the board. I just copied it from the book anyway. Don't sit there and try to write the whole thing down. You can go back and look at it afterwards. This is basically from last spring. So you can see here, and then that's where the video is. I post it unlisted on YouTube, so the only people that can see it are the ones that have the link to it anyway. But that means it works on any device you have. So you can watch it on your phone, you can do whatever you want to it. So it's there forever for you. Any questions about that? If you do click on important links, my email address is there as well, so you can click that and email me. The link for Desmos is there too. I use that quite often. So that's also there as well. All right, so that's my website. Now let's go on to the syllabus. All right, the syllabus that you got there is a shortened version of the syllabus that was online. It literally just cut out all the other crap that they told me to put in there. It's the stuff that you absolutely need, like my information, how to get the access to the class, your web assign code, and the dates for all your assignments. So there's my phone number. I can come down here earlier. I live in Hartford, so I'm not going to be here. Actually, I am here every single day. I'm here Monday and Wednesday mornings because I have a class at 9:30, and then I'm here Tuesday and Thursday nights. So if you want me to come down a little bit earlier on Tuesday or Thursday before this class to get some extra help, feel free to tell me that. I have no problem coming down and doing that. I'd be right across the hall in the adjunct suite. So there's my state email address. You can always email me. It comes right to my computer and my phone. So if you email me, I get back to you pretty quickly, or you're more than welcome to text me. That's the book you should have. It should be the exact same book you used last semester. And I believe you should still have access to WebAssign if you would use, I think Tish used it last semester too, and the other teachers pretty much use it there. So I believe you have access to it for like 2 years, the WebAssign. So you should still be able to have access to that. You should be able to have to put in my code. That's the class code you're going to need. I know probably at some point early next week, the syllabus is right there in the back if you want to grab one. Early next week, I'm going to get an email from the school saying that I need to put in attendance. I don't take attendance in class. So I'm literally going to tell them that you're here based on you signing into the WebAssign and you showing up on my roster there. So please make sure to do that as soon as possible. If you're having trouble with that, just email me and let me know. All right, any questions with that? All right, so this basically is what you'd see when you log into WebAssign. All the homework assignments are already there. The due dates are actually the due dates of the tests. So that's when your test is going to be for chapter 6 and 7 is February 22nd. And I believe I've said it now that you have like 100 attempts at it for every single question. So like there should be 0 reasons for you to not get 100 on your homework. Okay. I don't typically do homework. It's one less test. We're only supposed to do 3 tests in the final now instead of I used to do 4. So I'm using this, but it's literally there for you to practice. So keep trying the problems till you understand how to do them. My tests are going to be pulled directly from those questions. So if you can do all the questions on the homework, you're going to do fine on my test. All right, let's go back to here. You're sitting right in front of the syllabus, so you can just grab one. So homework is 20% of your grade. Like I said, you should not get anything less than 100 on that. If you get less than 100, try it again until you get 100. There is 3 tests. Each one's 15% of your grade. The final exam is 25%, and class participation is 10%. The 10% I basically give you, it's literally there, so I don't have somebody just show up and take the tests, which I've had in the past. So as long as you regularly come to class, or if you let me know that there's something come online, you're fine. You're going to get those points. So if I don't see you except for 3 times a semester, you're probably not going to get those points. So it's basically everybody starts off with at least a 30 in the class, and you go up from there. So you should be doing fine. We only have 30 more points to be passed in the class. That being said, I think I failed in the 14 years I've been here, maybe 3 or 4 students that have actively shown up. Like, I've had people who just did not come and failed out of the class because they didn't do anything. That's one thing. But as long as you actively come to class, and it's been a long time since I've had anybody fail that's actually come to class and done their work and stuff like that. So as long as you come, do your work, pay attention, you're going to pass this class. The tests, you have 3 of them, chapter 6 and 7, which is going to be on, the first one is February 22nd. The second one is right after spring break. That's chapter 8 and 9. Chapter 11 and 12 is the 23rd. And then your final exam is probably going to be the 7th or the 9th. I don't know the day yet. They haven't come up with the final exam schedule. They're making some changes to it from last semester as there were some issues with that. And making sure all the teachers know that there's a final exam schedule and don't tell you to come to class when you weren't supposed to be there, because I also heard that happened. So they're making some changes with that. As soon as I know when your final exam is, I will let you know. For the tests, you are allowed 1 index card for your notes, front and back. It can be 4x6, 3x5, whichever size you get. Those are the 2 standard size ones. You can handwrite anything you want on it in the front and the back of the index card. There's a very specific reason I allow you to use an index card and not open book. I have actually found that my students do better with an index card than when I did open book. Because if I give you open book, what typically happens to students is they spend the vast majority of their time searching through the notebooks in their book to find the answers and help and everything else on the questions because they did not study. By giving you the index card, I'm forcing you to study because you can only write down the stuff on the index card that you need help with. So while you're going through and doing your homework and everything else, if you have to constantly look something up, write that in your index card, and then you'll be fine for the actual test. So when I switched over to the index cards, my students actually started doing better on the tests than when I had open book. So that's why I do that. So it's not a punishment. There's actually some rationale behind why. If you get a 90 or above on all the tests and you've completed all the homework, you will be exempt from the final exam. So 90 or above on all 3 tests, and you've completed all the homework, which you should have gotten 100 out of them all, you'll be exempt from the final exam. You do not have to take that. So if you don't do that and you have to take the final exam, I take the final exam and I will replace your lowest test grade with it if it's better. So let's say you had a really bad day, you got a 60 on one of the tests. Obviously, you're going to have to take the final, but you took the final and got an 80 on the final. I replaced the 60 with the 80. Okay? So it's basically, that's how I take care of one of those days you just had a bad day. I figure if you can do that well on the final, you probably learn the material fine. So I'll give you the credit there. Any question on any of the stuff with the tests? Nothing too far out of the ordinary? All right. I think the schedule is pretty straightforward. I do typically do a review the day before the test. I will go over the homework assignments. So on the 20th, we will go over the chapter 6 and 7 homework. Maybe not every single question because there's a bunch of them, but I'll probably cut out a few because I know there's some duplicate ones in there. And I'll focus more on the ones that I know are going to be on the test, because by that point I'll already have the test made. Tests are typically around 10 questions. They will take you the class to do most times. I don't think there's any class after this point, so if you need a little extra time afterwards, that's fine. There was not a class in here before this point, so on test days, I will try to be here for 4:30. So this way you can come in earlier if you want and start your test earlier. That's fine. So I know there was nobody in here at 5. So I think that's it on the syllabus. Okay. Any questions on anything I just went over? We good? Awesome. Quiet class. All right. And let's work. Actually, everybody's here. Very nice. I do know that depending on what Calc 1 class you were in, and depending on how fast the teacher went or what they skipped and stuff like that, when the derivatives, some people have covered parts of chapter 6. I start off in chapter 6. It's a good review of it, the basic integration stuff you did in chapter 5 anyway. So, and then we'll move into the more complicated chapter 7. So, anybody not take Calc 1 last semester? When did you take it?
5 years ago.
Okay. The book might have changed since then. So it's actually the same book, it's just a different edition.
Well, the sign is familiar, but it's probably like forever since.
Yeah, so you're probably gonna have to get the code for that one. Yeah, I know we switched from the 8th edition to the 9th edition last year or the year before. So, all right. So area between curves. At this point, you should understand that integration finds you area. We're looking for the area underneath the curve. I will tell you right now, I'm not going to spend any time doing Riemann sums and stuff like that. So if you liked doing those, I apologize. We're not doing those. I'm going to assume at this point you understand what integration is, and we're just going to do the integral that makes sense, because that's what you're going to have to actually use anyway. So when you're looking at the area between two curves, we're looking at the area of the top curve minus the area of the bottom curve. We're going to subtract those off. Can everybody see the screen fine? Or okay. So when we're looking at this, that's what we're going to be doing. We're going to be doing the integral of the top function minus the integral of the bottom function over the same range or domain or interval, whichever one you want to call it. Then let's look at. Oh yeah, I can 99% guarantee that the vast majority of you have a TI calculator, because I'm pretty sure I know Professor Tish uses one. I don't care. If you don't, you are more than welcome to use Desmos on your phone. Just download the app and use that. It's way better. I can't see you spending $140 on a calculator if you haven't already done so. It's the same calculator that I bought in 1995 when I went to college. Nothing has changed with it, including the price. So it's the only thing that's completely and utterly recession proof. Like, buy stock in Texas Instruments, you'll last forever. All right, so we're going to look at the area between the y equals e to the x and y equals x. So the first thing you're going to have to do for these, unless you can visualize it in your head, is to figure out where the intervals for these are. So which one's on top and which one's on the bottom. I know this one tells you, but the vast majority of problems are not going to tell you. So you're going to have to figure that out. And the easiest way to do that is to graph them. So this is what Desmos looks like if you have not used it. An awesome, amazing graphing calculator. It actually can also do integration for you. So you can use it to check your answers. So we're looking at the curve from 0 to 1 for this one. So between 0 and 1, the red line or e to the x is on top. So that will be the f of x, and the y equals x will be my g of x. So we have that. So we're going to do the integral from 0 to 1 of e to the x minus the integral from 0 to 1 of x. All right, what's the integral of e to the x? Good. And we don't need c because we have, it's a, it's a definite integral. My brain's not working tonight. So we're doing that from 0 to 1. What's the integral of x?
X squared over 2.
X squared over 2. That's why I like this section. It's a nice review of those basic trig rules or integration rules. All right, so now we're going to plug in 0 and 1. The vast majority of time, 0 is going to cancel things out, but not always, and this is one of those cases. So we're going to plug in the 1 to the problem, and then we're going to plug in the 0, and we subtract those off. So if we plug in 1, I have e minus 1/2. And then minus, if I plug in 0, I have 1 minus 0. Because e to the 0 power is 1, not 0. So subtract those out. And I end up getting e minus 3/2 is my answer. Oh yeah, I'm also one of those teachers that if I make a mistake and I put it on the board, feel free to tell me. Don't sit there and goes, am I wrong? If you think something's wrong, tell me. I make mistakes just like everybody else does. No, I don't give you bonus points for it, but I do at least we'll fix things. Because one of the things I tell students is the majority of the problems that you're going to have in this class, just like in Calc 1, is not calculus based. It's algebra based. You're going to make mistakes with signs. You're going to forget e to the 0 is 1. You're going to put 0. Those are the mistakes you're going to make. So when you're going through and doing out your test specifically, show me all your work. Because if I see you've done the calculus correct, which is what I'm really testing you on, but you made a stupid mistake down below, I give you partial credit. If I don't see any work and I just see an answer and it's wrong, I'm going to mark it wrong. Actually, and if it's right, I'm going to mark it wrong because I want to see your work. So show me your work, and there's a very good possibility you're going to get partial credit for it. All right. Any questions with this one? Did anyone find this one difficult? Awesome. Would anybody tell me if they found this one difficult? Good. All right. If you find something hard, you have a question on it, ask. That's the way we all have to learn. So, all right. So let's look at this one. All right. So this one, couple things. First thing is they don't tell me which one's on top. What else don't they tell me? Yeah, they don't tell me the intervals, right? So they don't tell me where I'm starting and where I'm ending. They say they want the area that's enclosed by it. So that means we have to figure out where these two cross. Yes. So we're going to take these two problems. So I have x squared equals 2x minus x squared. Move everything over to one side. Factor and solve. Don't do this. Don't do that. Because you're going to lose some information. Remember, quadratics, set equal to 0, factor and solve it. All right. While mathematically that's correct, you lose information, you're losing the 0 term. So, little things. I will have a tendency, like I just did there, to show you the mistakes I regularly see. My biggest pet peeve is when people do this. That does not equal that. Don't do that. Which I also see quite often, especially when we start doing some more of the integration, as integration by parts and trig substitution and stuff, because they don't want to have to go through and do all the extra work. All right. So I've got my integral. I know it's going to be from 0 to 1. Which one's on top and which one's on the bottom? Can we tell just by looking at it instead of having to do out the graph? Well, x squared opens which direction? Up. 2x minus x squared opens down. So odds are which one's on top? The one that opens down. Because otherwise it would be not between 0 and 1. So it'd have to be somewhere else for that to work. So this one, the purple one's on top. So it's like, but again, just graph it. It's not that difficult. And one of the nice things actually about Desmos is when you graph it, you can also check your intersection points because it'll show it to you. So we've got 2x minus x squared minus x squared dx. All right, so what am I doing next? What should I do for this one? Yeah, let's get rid of the parentheses and stuff like that, put things together. All right, so now we can do our integral. So what's the integral of 2x? Yep, it's just x squared. Because it's 2x squared over 2. The 2's cancel each other out. What's the integral of negative 2x squared? Huh? Oh, yeah. Yep. The other really easy mistake to make is forgetting the direction you're going. Right now, we're just doing integration, but there's quite a few of the methods that we're going to learn in chapter 7 that does integration and differentiation at the same time. So it is really easy to screw up and go, oh, yeah, that's just 4x. Because that's the derivative rule for it. So it's really easy to make those mistakes. So just double check your work and stuff like that when you're doing it. Dx from 0 to 1. Now this time when I plug in 0, everything's going to cancel out, so I don't need to worry about the 0. So I have 1 minus 2/3, which equals 1. Because every scientific calculator does fractions, you don't have to sit there and play around with common denominators and everything else. Just use your calculator to do your fractions. You will have to do it when we start doing ones with variables, but like the easy fractions, don't screw them up. Just use your calculator to get the answer for it. I've seen people go through this entirely complex problem, get all the way down to the answer, and then write out all the work for doing common denominators and everything else for the fraction and mess it up. And it's like, it's not worth it to do all this work and then lose a point at the end because you messed up your fraction. So this one's 1/3. Questions? We good stuff? All right. Let's get more complicated. Let me actually write these out. All right. Figure out which one's on top and which one's on the bottom, and figure out the intersection points. Right. Try.
Oh, I don't even know where to start. No, it's been like 5 years.
Yeah.
I was gonna just
Pull up Desmos.
do the whole.
Put up Desmos and graph it. Start there. You'll be fine.
I already remember something.
I'm also using this as an ability to check and make sure you know how to use your calculators. So
Well, we stood on a huge computers.
yeah, I know. It's division.
Oh, that makes sense.
Yeah, just use the division sign. I'll tell you right now, there's no way you're doing that. So you have to kind of graph this one.
See?
Yeah. Yikes.
You were zoomed out so far.
What?
You were zoomed out. You were looking at like in the hundreds, which is why the other equation kind of disappeared. So just hit the little home button and it zooms back in for you. There you go. And now if you click on one of them. There we go. There's your intersection points. All right. So if you tried to actually put them equal to each other and have x over the square root of x squared plus 1 minus x to the fourth minus x equals 0, you'd realize really quickly there's no way you're solving this. So the only way that you could do this is to actually graph it. So we graph it. We see that the square root one is on top, which is helpful. And we see that the red one's on the bottom. And then if we click the 2 points, we can find our intersection points. So you notice in this case, they are not nice intersection points. Well, 0 is nice, but the 1.18 is not. So we're just going to use the 1.18 as my endpoint there. So 0 to 1.18.
I'm just supposed to see that.
Oh, yeah. What, that?
No.
Oh, no, when I'm writing down, I'm going to switch back over in a second.
Okay.
But thank you. I do that often. So if you catch me writing, ask. Because I've done that. Sometimes I leave that up there for a minute so people can see it, and then I just switch back over. Because my screen is not, it's what I'm sharing, so I'll switch between tabs to find things while I'm doing it. Or freak out Brian Kennedy and actually copy and paste things into the thing as people are asking me questions. All right, so this is what we're doing right here. So that is my integral I'm going to do. All right. So let's look at this. Okay. So that part and that part, pretty simple to do the integral, right? The thing that's going to mess everybody up is that part. All right. So let's look at that one.
I know it.
So let's look at just the integral of x over the square root of x squared plus 1 dx. Not you, because I think you figured it out. What's the trick?
Yeah.
Anybody have a guess? Not you two. Yeah.
Is it like the opposite of the chain?
Yes. What's the opposite of the chain rule integration? You are correct. Does anybody remember the name of it? Use substitution. So when you're doing u substitution, we need to pick something for our u, and then we're plugging it out into using that to plug into the problem. What's the thing that would be annoying in this problem? The thing underneath the square root, right? That's going to be the annoying piece. So let's set that to u. So I'm going to set u equal x squared plus 1. And now I have to do the derivative of that. And that gives me 2x. And amazingly, I have an x up here. I don't have the 2. So I'm going to pull the 1/2 out. Yes,
You took the derivative of x,
x squared plus 1.
you took the 1/2 out from what? Sorry.
So I have this 2 right here.
Oh, okay.
And I don't have a 2 up here. So I only have x, so I want to solve that for x dx.
Okay.
So this way I can replace it. So that's why I pulled out the 1/2. So now this integral becomes the integral of 1/2 of 1 over u du. And actually, I'm just going to put the 1/2 in the front. All right, since I have other things I'm going to do, sometimes when you do u substitution, you can change your intervals. So like I could have changed the 0 and the 1.18. But since I have to do those anyway for the x to the 4th and the x, I'm not going to worry about changing the interval or the intervals here. I'm just going to do the integration here and then go back to the x terms. What's the integral of 1 over u? Yeah.
Sorry.
Yep.
You go back to, I understand how you got 1/2 du equals x dx.
Yep.
I don't understand how you got to that.
Oh, actually, I messed up one thing. There's a square root there.
Okay.
Now, do you understand? Oh, okay. No, that's fine. I was like, after I looked, I'm like, oh crap, I forgot the square root. That's fine. All right. So we're gonna erase it. I'm gonna start over. No, you're fine. You're fine. These are the questions you should be asking now. All right. So I took this piece right here. So change colors. I took that. I made it that.
Okay.
Okay. So my red part becomes 1/2 du. Okay. Then I have the square root, and that became the u.
And it's
Thanks.
No problem.
like that.
And now I can pull out the 1/2, and I have 1 over the square root of u du. Got it. Okay.
Because we just made that bottom part you.
Yes. Yep. That's why I like chapter 6, because chapter 6 gives you a nice review of the basic integrations and stuff like that before we go into chapter 7, where they're really complicated. Some people do chapter 7 first, and I do not know why. All right. So we're good to that part? Okay. So now I got to find the integral of that. So I can take the 1/2. I can change this to u to the -3/2 du. No, not 3/2. 1/2. I did the integral in my head. So it was at the same time. And then I did it wrong because I did the derivative. All right, so we got -1 u to the -1/2. So now I can do my integral to that. That's just the power rule. So I'm adding 1 to -1/2, and I'm going to get 1/2. And then it's u to the 1/2 over, u to the 1/2 over 1/2. That's what I want. So I end up getting it just to be u to the 1/2 or the square root of u. Yes.
Sorry.
No, you're fine.
U to the -1.
Yep. Integral of it.
Oh. So Oh,
Add one,
and then
bring it down.
Okay.
Yeah, it's with the fractions, it makes it a little more complicated because it doesn't become a fraction out in front. It's underneath, which then flips over and becomes a 2. So
Gonna make it fall. So I don't remember the difference between the two. I know one undoes the other one.
so yeah, derivatives are looking for slopes. No, you're fine. It's been that long. No, you're fine. So so derivatives and integration are inverses of each other. So they're undoing each other.
Like multiplication.
Correct. So your derivatives are looking for slopes, looking for how the curves changes, and there's a variety of things that. Integration is typically looking for the area under the curves and the space there, and then we use that to do a bunch of other things, which is what you're going to learn here, basically.
So this is really bad. So I took like all the math classes up to calculus 1.
Yeah, and then you
I
stop for
never knew the point of what we're doing. Like I had the type of professor that was just like, this is the formula, deal with it.
oh
And
god,
they never explained what was going on. So I
just ask me.
well,
I
he's
could-
a mechanical engineer. So like I asked him and he was like, I just can't even answer a simple question like that. He's like, just go to class and just try it out.
Oh god,
I'm like, dang.
I taught high school for 24 years. You can ask me. You can ask me every dumb question you can think of, and I'll answer it because I've answered them all
Like
before.
a professor per se. And so I'm
Yeah.
like, what am I doing? Told us
God.
what we were doing.
Yes, ask me those questions. Did I answer your question? Though?
Yes.
Awesome.
I
Okay.
think we're related.
Yes. All right. So we've got the square root of u. What's u? Right. So this is really the square root of x squared plus 1. Well, it did. I got rid of the x and I moved it up top. So something did change. Oh yeah, and I never delete any of my slides. So for some reason I switch to the next slide and you go, wait, I'm lost. Just tell me. I'll go back. I know I'm not done. No, we're not done yet. So this right here, we just figured out is the square root of x squared plus 1. I'm going to distribute these signs. So this is negative x to the 4th plus x. What's the integral of negative x to the 4th? Yep.
Yeah, we got rid
And the integral of x is x squared over 2. And we're still evaluating this at 1.8 to 1. Actually, let me write that in a different color. So I just distributed that. And yeah, if I skip a step and you don't understand how, just ask. That's fine. I have time built in the schedule. If it takes me longer to go over something than I expected it to, it's okay. I can move things around fine. All right. So now this can be a pain in the butt to do. So I'm going to show you a nice little trick.
it.
Yeah, I want to make your life easier using a calculator.
You substitute.
Do you allow calculators sometimes?
Yep.
Maybe have-
I will find out. I could figure out pretty quickly if you're using like Photomath and those other things to cheat so that I'm not overly worried about it. Because if I catch you, then I'll deal with you at that point. Like I said, like if you have a graphing calculator, the graphing calculator is going to work for everything I'm going to show you anyway. But if for some reason you don't go spend the money on one. All right, so here's Desmos Scientific Calculator. One of the very cool things that Desmos Scientific Calculator does is you can type your formula into it and then put the answer. So x equals 1.18. And it will give you the answer to the entire problem. And then I can just change it to a 0 and it'll give me the answer for that one. So, and it'll work for any formula. So like you can type in, like if say you're looking for the area of a bunch of triangles, you can type in the area formula for triangle and just change B and H. Yes.
You guys are nodding. I'm so screwed.
You will be
You're
fine.
like, this is great.
You will be fine.
It's nice that I know I'm not gonna make a mistake of plugging stuff into a
And
calculator.
then I'll just.
I do that wrong.
It's just
My Sundays, you do
Yeah.
that homework like 20 times.
And then you can email me while you're doing it on Sunday and say, hey, I'm stuck. and I'll answer you.
I'm gonna email you during the test. I don't get number 3.
What's the answer to 3? Sorry, can't help you now. All right. So we got 1.785 minus 1. So the final answer is 0.785. If I don't tell you, round everything to 3 decimal places. Yes.
So I know you said you could get Desmos on our phones.
So you can do it one of 2 ways. You can download the app, which is fine. Or you can literally just go to the website. It's the exact same as the app. Oh, you can use it.
I can have a laptop out.
That's fine.
on
Yep.
Desmos.
Yep.
What about GeoGebra?
Honestly, I find Desmos a lot more user-friendly and easier to use than GeoGebra, but if you really, truly like GeoGebra instead, it's fine. I don't necessarily have a problem with that. It's not going to do anything really different. I was excited the other day when I found out that Desmos added in a 3-dimensional calculator and geometry tools. So that made my life a lot easier. So I left full-time teaching in high school in 2022. And now I'm writing math books. I'm working for a publisher writing textbooks. So everything we have to put in, we have to like, put the links and stuff. So Desmos works really well. We're now doing the Calc 2 stuff, which has 3-dimensional stuff. And I had to do 3-dimensional graphs. And when Desmos put it in, I'm like, yes. Because GeoGebra was nice, but didn't quite work the same way we needed it to. All right. So we got that answer. All right. So as you can see, like in essence, the process of finding area under the curves did not change. It doesn't matter what the problem is. The stuff that changed is how you had to do the integration for that problem. So those things become a little more complicated. That's what Chapter 7 does, and that's why I don't know why anybody does Chapter 7 first. Chapter 7 goes through a bunch of more advanced techniques on how to find integrals. So use substitution, the basic ones, but there's a lot of problems you can't do that way. And that's what Chapter 7 really tries to cover. So we're going to go through Chapter 6. We're going to do some easy stuff first, and then we'll move into the more complex math in Chapter 7 once people are comfortable doing the basic integration again. All right, let's look at this one. All right, so that's what we're doing. So graph sine and cosine. Maybe. All right, so there's the graphs for sine and cosine. When you're playing with Desmos, this little wrench key over here, if you click it, you can change your axis, like where you're looking. So like this one's looking from 0 to pi over 2, you can change it to only look at 0 to pi over 2. So this way you're only looking at the interval you need to deal with and not have to deal with all the rest of the stuff on the graph. Sometimes it's helpful, sometimes it's not. This one, it actually is very helpful. What do you notice about these two graphs? Yep, that's the way sine and cosine work. Which one's on top?
Yes.
Yes?
Yeah.
Cosine starts on top. And then, right, and then sine ends on top,
I
right?
don't know. I think cosine's on top because greens overlap with blue.
Okay, but that's what I'm saying. And then on this side, it switches. So this is actually a very important thing when we're looking at area under curves. If I found the integral of this as it states right now, so if I took it and did the integral from 0 to pi over 2, and we'll put cosine on top first, and then I'll do the other one. Oh, did I not? I ended it. Oh, I know why. Hold on. Darn parentheses. There we go. You get 0. Does that area look like 0? No, there's area there. So that answer doesn't make sense. Okay? Because these graphs cross in the middle of my interval. So that means I need to do 2 integrations to look at this. I have to do the integral from 0 to pi over 4, which is actually where they cross. And then from pi over 4 to pi over 2, because the top function changes at pi over 4. Okay? If you look at it, this side and this side, what do they look like? They look like the same. They're symmetric. So in actuality, I can do one side and just double it. That's not always going to be the case. Sometimes it doesn't work that way. In this case, it does. But the big piece is you cannot look at the integral from one side to the other side because the lines change. So we have to actually do this twice. All right. So when we're going back here, so we're going to change and set up 2 integrations. We're going to look at from 0 to pi over 4. And on this one, cosines first. And then we're going to add pi over 4 to pi over 2. And this side, sines on top. All right. So since we're really only doing the integral of sine and cosine, we don't have to do this necessarily multiple times. What's the integral of cosine? Okay. Yes, it's sine. So for those of you who do not remember, or even if you took it recently, don't remember, the derivatives, sine of x, cosine of x, negative sine of x, negative cosine of x, and then repeats. So this side is derivative, and then you go backwards for the integral. Okay, so since we're at cosine of x, we go back up to sine of x. If we were at sine of x, we go to negative cosine of x. So the integral of cosine of x is sine of x, and the integral of sine of x is negative cosine of x. Okay. So the sine and cosine has it just repeats itself every 4. So nice little thing to keep in mind when you're going through and doing it. All right, so I've got sine of x plus cosine of x from 0 to pi over 4 plus negative cosine of x minus sine of x from pi over 4 to pi over 2. Questions with that? Yes.
How much do you emphasis on exact values?
I like exact values. I would rather exact values at all costs, except for unless you absolutely can't. Like in the last problem, the interval point was 0.1.18. There was no way for us to get an exact value. There's no way for us to solve this to get an exact value. In this case, there is a way for us to get an exact value. So I'd prefer the exact value over a decimal approximation. I'm one of those people as it's, I'm not going to mark the problem wrong if you have the right answer. I'll probably take off a point if you give it to me in decimals instead of the exact answer. Just because I have seen situations where people don't have to use the exact answers and then have to use that number somewhere else, and then the answer gets way wrong really quickly. I know this is before the vast majority of your time. The Hubble Space Telescope went up in 1990, and it was blurry because a guy who created the lens, who actually was in Danbury, Connecticut, because that's actually where the lenses and stuff were created, screwed up his conversion between standard and metric, and was off by was it 1/1,000,000th of a place in their decimals? It was like less than the width of a human hair that they were off on. But on that big of a lens, it was off. So it's one of those things like if you can give me exact, I'd rather that. Like even with fractions, I'd rather a fraction over a decimal. So
What you're telling me is never convert.
like in this situation, because I know that's why he's asking it, use the unit circle, get me the exact value. It's going to make your life a lot easier. All right. Because I know that's where this one was going because it was a sign problem. All right. So what's sine of pi over 4?
Oh, sorry.
Root 2 over 2. Cosine of pi over 4 is root 2 over 2. Minus sine of 0. Cosine of 0. Yeah. Plus. We already got that one. That's the negative square root of 2 over 2. Or minus. Did I screw up the signs of that one? Hold on.
I have negative cosine.
So sine goes to that one. That's right. And cosine goes to that one. Okay, that's right. I screwed something up. I'll figure it out in a second. Oh, I know why. I know why. Anybody have a guess where I screwed this up? I did the bottom first.
Yeah.
Have to do the top first. Cosine of pi over 2 is 0, so it's 0. Sine of pi over 2 is 1. And then minus negative square root of 2 over 2 minus square root of 2 over 2. I was like, I know they don't cancel each other out. That's how. So like when you're going through and doing your problems out, I'm going to do the exact same thing on the board. I'm not one of those ones who I don't have all these pre-planned. I'm literally writing them as I am in front of you. Okay. So if I make a mistake, I'm literally going to figure it out right in front of you. The reason I do that as compared to being the perfect teacher and have everything with PowerPoints and everything done out is that's what you should be doing. When you get to something that doesn't make sense, you need to figure out how to do it. So modeling, that's not a bad thing. So go through and look at it. It's like, and those are common mistakes that are made, especially considering we just found it. It's like, oh, I already know that one. Well, yeah, but your sign's not going to be wrong. So little things like that are useful. All right, so we got square root of 2 over 2 plus square root of 2 over 2, which is just square root of 2. Minus 1 plus square root of 2. So I get 2 square root of 2 minus 2. And that's my final answer. Yes.
these have problems, it just assume that the Julian curve would be.
Yeah, in this case, because we said they look symmetric, and they come out to be 0 if I did the area. So yes, they would absolutely figure out that they would be symmetrical in that respect. So you could have done just 2 of one side. So if you did the one side, you got square root of 2 minus 1, and then multiplied that answer by 2, and still would have gotten the same answer. Either one of those would have been correct. That's actually also a very important thing when you're looking at especially with trig functions, because there's lots of different ways to do like breakdown your trig integrations using different identities and stuff like that. I don't need your answer at the end to look exactly like my answer as long as it is correct. So when you're going through and doing out your problem, as long as everything you're doing is mathematically correct, if your answer at the end comes out slightly different than mine, like this one's obviously not, but some of them will come out, you'll have like with sine squared or sine squared plus 1, things like that, where like it might be slightly different because you used a different identity than I did. I will take your answer and my answer and I'll plug them into the graphing calculator. If they're exactly the same, you're good. So it doesn't necessarily mean you have to do it the way that I did it if you have another way that's easier and it's mathematically correct. So, all right. Questions with that one? Okay. So remember, when you're looking at this, this is the one, and I typically try to do ones in class that have those little catches like this one where you have to figure that piece out, because I'd rather you figure that out now than get in your test or homework and get stuck. So, all right. All the problems that we did so far were looking from the x-axis and going up. Okay. Not every equation is done that way, or that's the easiest way to look at it. Sometimes we want to look at going to the y-axis. I think so. Nope. I'm not muted. That's the wrong. That screen's muted. Mine's not. Otherwise, you get an echo if I don't mute that one. All right. So when we're looking at this, we can look at it going to the y-axis as well. Because sometimes an equation is actually easier to be done if it's solved for x equals instead of y equals. So when we're looking at this one, we're looking at going towards it. So it's going to be the rightmost equation minus the leftmost equation. Right? Instead of top and bottom, it's right minus left. But other than that, everything else is exactly the same, except it's typically done with dy instead of dx. So like if you look at this one, we have y equals x minus 1 and y squared equals 2x plus 6. So if I wanted to solve this one for y's, to do it that way, this one would end up being the square root of 2x plus 6. Can you find me the integral of that? Not easily. Actually, this one's not too difficult. The u substitution on this one wouldn't be too bad because the x disappears. But typically, you don't want to deal with square roots. It's going to be easier for us to solve this for x instead. So this one would be y plus 1 equals x. This one would be 1/2 y squared plus or minus 3 equals x. Yeah. So now I don't have to deal with any square roots. It makes my life lots easier. Now the question is which one's on the left, which one's on the right? This is easier in Desmos than a graphing calculator. Because in Desmos, it doesn't matter which one you use. So when you're looking at Desmos, I can type it in as x equals. You can on the graphing calculators, except you have to actually go and change the setting so it looks at the x instead of the y. This one, you just type it in. All right, so we're looking at where it crossed or intersects. So we're looking at from there to there. Which numbers am I using for my interval?
Right, left.
Yes. So I'm going to do blue minus green in this situation. But which points am I using on my, which interval am I going to use for my integration? Y negative 2 and 4, not negative 1 and 5.
Because you're doing it with respect to the y-axis, not the x-axis.
Correct. So the ones that we've looked at in the past, we looked at the x. Okay. And that's typically what you'd look at. When we're looking at domain, we'll look at x. However, this one we're looking at in terms of the y. So we're going to use the y values, not the x values. So we're looking from negative 2 to 4. Yes.
And it's not 4 to negative 2.
Oh, no. When I write the interval, it's going to be 4 and negative 2. Yes. When I write on the integral, give me a second. I know what you're asking. When I write my integral, the negative 2 is at the bottom. Because we're going from negative 2 to 4. It's the same.
Left to right.
Yeah, it's still the same rules. Yes, exactly. It's still the same rules as you would do for the x. The nice thing actually is if you do this, if you did it backwards, what's the only thing that's going to happen? You're going to have the wrong sign. Your area is going to be negative. Can I have negative area? No. So you're going to catch your mistake. And at that point, the actual answer is no different. The answer stayed the same. It literally just changes the sign. So, all right. So we're going the x minus 1 minus, oh, sorry, not x minus 1, y plus 1 minus, it's like, no, wait, hold on. He said y. You will be fine. Trust me. It'll take a little bit, but it'll start to come back and click.
Remember, like,
Yes, it'll come back and click. The nice thing about this now is it's just all power rule, right? I don't have to deal with your substitution or anything else like that. If I did the square root one, I'd have had to deal with your substitution. The answer actually would have come out to be the same. All right, that's the nice thing about doing this. Like, if it depends on the direction you go doesn't really matter, because if I did it the other way, the graphs would be the same. It'd just be on the x-axis, so this area between them will still go be the same. Yes.
Would you ever want us to demonstrate one method over another?
Nope. I'm nice like that.
For after you teach them parts, like setup, formulas and stuff like that, you're not going to do like that. Because
Not on the test. On your test, I'm literally going to give you, here's a whole bunch of problems. I want you to find me an integral of it. I don't care how you found them. I will tell you right now, there will be certain problems that you can't do any other way. But that's actually part of the test, is literally making sure you understand how to look at the problem and figure out what method you're going to use. Okay, so I am not going to tell you, use the integration by parts for this method or use partial fractions for this problem. I'm not going to do that. You are going to have to figure out which method you're going to use for that. Okay. It should be by the time we get there.
Okay.
It won't be if I show you a problem today, but after I taught you the methods and everything else and I explained to you what ones go where, you should be able to do that. If I've done my job well. If I didn't, you'll be stuck. All right, so let's do the integral for this one. All right, so I'm going to do a quick little thing. I'm going to put the 1 and the -3 together, so that's plus 4. So the integral of y, yeah, y squared over 2. And the integral of negative 1/2 y squared.
That's why.
Right. So negative 1. So y3 over 6. 2 times 3. And then the 4 becomes 4y. Don't put an x. Really easy to do that because you're like conditioned to always use x's. In this case, it's 4y. All right. Plug our numbers in. So 4 squared 16 minus or divided by 2 is 8. 4 to the third is 64 over 6 plus 16. Two. Negative 8 over 6. 8/6 minus 8. So I have 16, 32, so 30. Minus 72 over 6, which is 12.
Yeah.
So 30 minus 12 is 18. You'll notice I didn't simplify my fractions here. I just left them. It's not because I realized they were going to cancel each other out at the end. Why do it there when I can do it later if I have to? Because sometimes you'll do it and then you'll have to go back to it and it's annoying. So just leave them there, and when you need to simplify them, simplify them. There, we're gonna do that problem. I'm not going to do this one. I want to do a word problem. All right. Any questions with this? Which majors do I have in here?
Biochemistry.
Okay. Yeah. Right. Anything else? Business? Huh? Oh, your math? Okay. Anybody else? Huh? Science, okay. No, the reason I'm asking is actually a very specific one. When I get to chapter 8, I have a choice on which sections I pick to do the application style stuff. So I'm going to pick ones that fit you. So I will do the biology section instead of the physics section, for example. I don't particularly care for physics either. So,
Problems I had to take out to, I've taken every chemistry course, every math course, and then I was about to graduate and they're like, you have to take chemistry.
that's crazy. But it also means that when I'm picking like word problems and application style problems, I want to pick problems that will relate to something you're going to do, so that you can see how this is used. So that actually does help me. All right. So, and this is why I was coming to it, because I want to do an application style problem. So this one is the birth rate of a population is B of T equals. Actually, I'll write this because they're really small. So 2200 e to the 0.024 t, and the death rate is 1460 e to the 0.018 t. So we're looking at from 0 to 10. What's the area represent before we actually find the area? What's the area represent? Kind of. Yeah.
The difference between the total people per or
Deaded.
Net gain of people.
Yeah. Okay. Yeah. It's what were you gonna say? Yeah, it's actually gonna tell you at the end the population change. So yes, each one of these, like the B will tell me how many people were born, the D will tell me how many people died. The difference between those areas tells me the actual increase or decrease in the population as a whole. Okay. So that's what we're looking at in this situation. The nice thing is if you look at these two, it's pretty obvious to tell which one's on top and which one's on the bottom. Births is going to be on top, it's bigger to start with, and deaths is going to be on the bottom. So we're going to have a population growth in this situation. So we're going to look at our integral from 0 to 10. And we're going to do the 2200 e to the 0.024 t minus 1460 e to the 0.018 t dt. All right, take like 5 minutes and try this problem. All right, for those of you that are stuck or That's the first goal. Because I have a function inside of the U, you have to do U substitution. Now, this could be an implied U substitution, depending on how well you are with your U substitution. And you don't necessarily have to write the whole thing out. However, you do need to do U substitution. This one, if you put it as a decimal, it's okay because there's already decimals in the problem. It was just easier to do it as a fraction in this case for me. My final answer is going to have a decimal in it anyway.
2.7
Uh,
at the bottom.
yeah, it's 275,000. Desmos actually will do it for you. If you click the little button right next to it, it'll change it to a fraction for you. Yes.
I got as far as du over 0.024 equals dt.
Good.
And I was trying to figure out how to put it back in.
So you're going to change that becomes the U. And actually, the only thing I did right here was du. And then remember, when you're doing integration or differentiation, you can always pull out the constants. So I pulled out the 2200 over what the fraction was going to be.
Why over what? Next one.
Because I did that over here. That's
Okay.
that part over there. Yes,
Sorry.
you're fine.
So I pulled out the 2200.
Yep.
2200 and the integration of e to the u du.
Yep.
How does du over 0.024 equals dt go into that?
So
Do I turn it back into dt?
no, so this replaces the dt. So there was a dt here. I know because it's not writing. Right. There was a dt there. That got replaced with this and that. That's the one over the 0.024. So I had this 2200 e to the u times 1 over 0.024 du. That's what I had. And I pulled out that and that. And that's what gave me that part in the front. Because those are all constants.
Then I'm gonna go back to the next part.
I used Desmos. That to the 275,000 over 3, that's what that equals. And the integral of e to the u is e to the u, so I just resubstituted back in what u was.
So you did half, what, 1460?
I only did half the problem right now. That's the other problem. That's on my next page. But it's literally the exact same process, just with the different numbers. I will show you that one in a second. Yes. Oh, I just plugged that into the fraction into Desmos, and that's what it gave me. It's if you get it as a decimal, it's 91,666.667. So I just left it, I just left it as a fraction. And then the death one is literally the exact same process, just with a different number.
Oh my goodness. I went from 0.0 and 0.024.
Yep. So put it all together. When it's 10, that's the number. When it's 0, that's the number. So I got 19, 4, 24, because we can't have half a person, and 10, 25, 6. So we have a gain of 8,868 people. And I'd round to the nearest whole number because, again, can't have a half a person.
I mean, you can, it's just not ethical.
Yeah, true. And they're not going to be really walking around very
Maybe
well.
count the conjoined twins or any other potential mishaps that happen in both. So,
They're still a person. They still count as one.
Joint twins are count as two.
No.
I think they are legally two different people. They have two different legal
It
names.
depends on where they're connected.
I guess it depends on where they're connected. If they have two heads, then yes, there'd be two
We did not
people.
account for this. So,
See, lots of changes there. All right, so we've got 8,868 people gained in this place. All right. Questions? How many people are totally freaked out and lost them? Only a few.
Sorry, I have a question. I'm not.
Totally. Wait, come on.
I was
No,
thinking
it's-
of the
Yeah, I think it's fine.
I have, so for the first part.
Yep.
2,200 over 0.024 times e to the 0.024 t from 0 to 10.
Yes.
I got not that.
Okay. You did it differently.
Yeah.
Because you did just this.
Well, my plan was to do just that.
Right. And then subtract the other one. Yeah, you could do that.
Okay. Oh, you didn't do that.
I didn't do that. I did the 10 and I did the 0 for the whole problem. That's why you got a different number. Your final answer should be the same. But yes, you could do that. You could do this one for the 0 to 10. That one from the 0 to 10. Yeah. Yeah, no, that's fine. Totally acceptable. So, all right. You can start the chapter 6 homework, but chapter 6 homework is all of chapter 6, which includes volume and stuff like that we haven't gone over yet. So you're more than welcome to start the homework on the website. You're not going to be able to finish the homework on the website, which is not a problem.
how many questions do I have?
12 in chapter 6. But like I said, do you have 100 attempts on them all?
How will I live?
So I purposely did that so you could keep literally practicing as much as you want to practice. It'll always take the highest grade you get, which should end up being 100 at somewhere in the end. So practice it. If you want to go through and do them all, that's fine. Make sure you do log into WebAssign and sign up so you're on the roster there so I know you're here. Everybody showed up today, so I'm going to mark everybody here anyway because I know everybody's here. But yeah, so any other questions, feel free to stay and ask. I'll be here for a few more minutes before I leave. If not, drive safe. I know it's probably getting icy out, so hopefully tomorrow morning is not that messy.
I'm gonna drive like a maniac.
Well, you know,
You know, maybe I'll get a little bit lucky and
Today?
just drift all the way home. Huh? Oh, Desmos. DSMOS. Hold on.
One day I was
There you go.
actually driving home,
Oh, this
right?
Yeah.
It was like 3 a.m. And I went to
Yeah, if you Google that, it'll come
5
up.
miles an hour, like,
Yeah, if you Google that, it's
and
the
I
first
just
thing that
started
comes up.
drifting, and I just, oh no.
I was ripping out the cake.
If you Google it, it's the first thing that comes up.
All right,
I was
okay.
trying to get this
But also, for the website,
Yep.
because I was trying to work in for last night.
Yep.
Right, thank you.
All right, let's see.
Because I think the code is only for one semester. I don't know.
I thought the code should last longer than 1 semester.
Uh,
That's not what I wanted to do. That's what I wanted to do.
Depends which one you bought.
Yeah.
No, I think I might work for the only.